Alright, so today we're talking about section 11-2, which is starting our discussion of surface area, specifically for prisms and cylinders. We're going to start off with a little bit of vocabulary. So, if you read along here, a prism is a polyhedron with two congruent and parallel faces. So two congruent and parallel faces. So if you're looking at the pictures I have below, these are all different types of prisms, right? If you notice, they have different names. So this first one is called a rectangular prism, and that's because one of its bases is a rectangle, right? So this is the base here that's already colored in for you. It's the shape of a rectangle, so we call it a rectangular prism. We have a hexagonal prism, pentagonal prism as well. But the important thing here is, if you notice this colored, let's look at the pentagonal prism. So this, the pentagon is our base, and we know that because it has an opposite base that is congruent to it and parallel to it, right? You cannot say that, oh, this rectangle here is our base, because the opposite rectangle is not parallel to it, right? That's not a characteristic of pentagons, where the opposite sides are parallel necessarily. Okay, so unless they specify, you can't assume that they are. Same with the hexagon. We call this our base, right? We have a hexagon-shaped base because the opposite sides are congruent and parallel, and the other sides here, all the other rectangles on the side here, are called lateral faces. So basically, lateral is just a fancy way of saying on the side. Okay, so if you want to put a little star here for all the lateral faces, you can just put on the side, if that makes it a little easier to see. So again, the bases are the parallel ones, the lateral ones are the other ones. But if you notice on one of these specifically, if you notice on the rectangular prism here, it says that, or it's labeling this side here as your base. But with a rectangular prism, the top could also be your base. Because if the top is your base, is the opposite side congruent and parallel? Well, it is, so that could also be called our base, which means the other four on the outside, right, this one here, this one, the one in the back, and this one here, the other four would all be called our lateral faces. So if you're dealing with a rectangular prism specifically, you need to specify what you're going to use for the base, but you're going to get the same result regardless, and we'll look at why that happens in a little bit. So let's do a little vocabulary check. So we're looking at this first picture here, and we want to see, is this a prism? If so, where's the base, where's the edge, where's the where are the lateral faces, etc. So we have a pentagon, we have an opposite pentagon that's congruent and parallel, and they're not going to put symbols to say that they're congruent or parallel. It's kind of like if it looks like one, which I always tell you not to do, right? I can't, if it looks like one, don't assume it is, but when dealing with prisms, yeah, you do. So this would be called a pentagonal prism. So yes, this is a prism. That's good. What about this one? Well, again, this is rectangular because all the sides are rectangles. So let's just pick one to be our base. I could pick the front one to be the base if I want, because the one behind it on the opposite side is parallel congruent. So those would be the bases, which means these four other sides here going around there would be my lateral faces. Right, but yes, that is also a prism. So that's good. Rectangular prism specifically. Now let's deal with this one on the left. We have the same concept. It's going 90 degrees. We again have a rectangular prism. Well, this one's not 90 degrees. Sorry, this one is not 90 degrees. It's slanted. So is that still a prism? That's the question. Well, what is a prism? Again, it's, first of all, is it a polyhedron? Yes, right? It has all polygons for faces. Do we have any sides that are congruent and parallel? Well, this top one is congruent to the bottom one down here that you can't really see, right? It is congruent to it. Let me just draw it in here. And they're both flat, which means they're both going to be parallel. So even though they're slanted, they're both parallel, which means this is still a prism. In fact, they have different names. So this one that goes 90 degrees here is actually called a right prism. And this one that's slanted is called an oblique prism. So they have two different names. There are a right prism and an oblique prism. So now let's look down here. We have two cylinders here. One's a right cylinder, that's this one, and one of them's an oblique cylinder. But are they prisms? So again, if you look at the definition, if you go back and look at the definition, it is a polyhedron, right? It's a polyhedron with two congruent and parallel faces. Well, they have two congruent and parallel faces, that's good, but they're not polyhedrons because this circle is not a polygon. So these are not prisms. They're cylinders, so that's why it's a separate category. But we still, same concept here, we call this a right prism, and we call this one an oblique prism. I'm sorry, a right cylinder and an oblique cylinder. They're not prisms. Okay, cylinders are not prisms. Alright, let's move on. So, if I said that you wanted to find the surface area of this rectangular prism, okay, I have a rectangular prism, what you're going to want to do first is figure out what the base is. So I'm just going to say, just for fun, I'm going to say that these sides here are my base. Again, you could pick the top ones, you can pick the front ones, the front and the back, you could pick any combo you want, as long as they're parallel and congruent. So I'm picking the orange ones. All you're doing for surface area is you're finding the area, right? The concept of surface area is finding the area of all surfaces, right? So find the area of each and every surface. So let's look at the long way to do this first. I'll show you the short way. Oh, again, to know the area of everything, you need to know the dimension of everything. So you're just going to do some labeling here. Since this is 8, all of these side lengths here are also 8, right? So because they're rectangles. So we have 8 on top and bottom. We have 4. So since this is 4, then all of these side lengths here are also 4. So I can call those 4 as well. And since this height is 6, then all of my heights are also 6. Okay, so I can put all of that there. Now, it might be easier to visualize this if we draw what's called the net, meaning again you unfold this shape. So I have a picture already. I'm just going to insert it in here. If you want to draw it yourself, you may do so. But if I have a net here, it would look something like this, where again 4, 8, and 6 are my side lengths, right? So I have a side length of 4 and 6. The orange, so I'm going to highlight them in here. 4 by 6, 4 by 6. Those are the two orange sides there. If I want to do a little color coding, just so you can kind of follow along here, the yellow ones are what? They're 8 by 4. So where are my 8 by 4 sides? Well, those are here. These are the yellow ones. 8 by 4. And then the front and back, we'll just leave them clear. Those are the ones that are uncolored. Those are the ones that are 8 by 6. Okay, so you should see some color coding there. I'm going to keep the orange ones colored in just so you can see. Well, if I wanted to find the surface area here, well, what would I end up doing? Well, let's just deal with this entire yellow rectangle here. If I want to find the area of all 4 of these, couldn't I just find the area of the entire rectangle, right? Well, what is the area of the entire rectangle? Well, this length here, again, is what? This is 8. And what's this whole length here? Well, it's 4 plus 6 plus 4 plus 6. 4 plus 6 plus 4 plus 6, right? Which gives you 20. So this entire length here would be 20. So the area of this whole middle part here, right, or the area of my lateral faces, okay, these are, again, all the non-orange ones make my lateral faces, right? So we call that the lateral area, which is just the area of your lateral faces, would just be 8 times 20, which is 160 square centimeters. Right? Well, what's the area of my bases? The bases would be, let me make some space here. The bases would just be, actually I can just write it right here. The area of my bases, so the two orange bases, would just be what? 4 by, this is 6, right? So I have 4 by 6 times 2, because there's 2 of them, which 4 by 6 gives me 24, times 2 gives me 48 square centimeters. So my total area, my surface area, would just be 48 plus 160, which is 208 square centimeters. So that would be your answer. Now let's look for a little pattern here. I'm going to go backwards. So hopefully you at least copy it down. Now there's a way to shorten this where you don't have to redraw everything every time. Okay? So if you notice, to find the lateral area, what did we actually end up doing? Well, we just took the, again, that's the area of this yellow rectangle here, right? The yellow rectangle. We took the side lengths of each of those separate rectangles and added them up, right? To give us 4 plus 6 plus 4 plus 6, which is 20. Well, what does that look like on our actual shape here? If we have 4 plus 6 plus 4 plus 6, isn't that just the perimeter of my base? Right? You could look at the other side too. 4 plus 6 plus 4 plus 6. Alright, that's just the perimeter of that base there, which means really the lateral area we just found by looking at the perimeter, right? The perimeter times what? What do we multiply it by? Times 8. Well, this 8 we can call the height. Alright, so the lateral area is really just the perimeter times the height. Okay? So this is key. You need to know this. This is true for any prism, not just rectangular prisms. Any prisms. The lateral area is the perimeter times the height. Now, if you forget this, if you forget that it's just the perimeter times the height, you can do what we just did. Look at each individual shape separately, right? You without even drawing the net, you could do this. You could go to here without identifying a base or anything like that. You could look at this and say, oh, well, again, this is 4 by 6, so that's 24. 24. This is also 4 by 6. That's 24. Okay, add that up. This is 8 by 4, so that's 32. This is also 8 by 4. That's also 32. This is 8 by 6. That's 48. This is also 8 by 6. Also 48. Add those all up, and you're going to get 208 square centimeters, which is the same answer. Okay, so if you forget the formula, don't panic. You can always figure it out. Okay, but we weren't done. It didn't say find the lateral area. It said find the surface area. So once we found the lateral area, we had to still find what? The area of my two orange rectangles here, right? The area of my bases. So the surface area is just the lateral area plus the area of your two bases, or the perimeter times the height plus the two bases. Whichever one of those you want to memorize, go for it. It does not matter which one. Okay? It does not matter which one. Alright, so we're just about out of time on this first example. On the first part, so I'm going to move on to part 2. So keep watching. I'm going to go over some more examples for you. See you guys.